All right, wanted to put together a video to look at the solutions to the Chapter 5 quiz in case we didn't have time to do all of them in class. So anyway, take a look at the first one here. I'm always looking at the inside function. I'm trying to reverse the chain rule first. I noticed the derivative of the inside function is 7, and I don't have a 7. So I'm going to multiply my function by 7. I usually put it over by the dx. And since I multiplied by 7, I've got to balance that by dividing by 7, and I'll factor that 1/7 out in front. Okay, at this point, you reverse the chain rule. Derivative of the inside function is absorbed back in. And you're just reversing the derivative process at that point. Okay, it's a power rule situation. Raise the power by 1, you divide by the power, you've got that 1/7 out in front. Should end up being 1/35 times the quantity 7x minus 2 to the 5th power. Don't forget your plus c. Okay, number 2. It's a 4x e to the x squared. The 4 doesn't exactly do what I needed it to. I'm going to pull it out front. I've got the e to the x squared. I'm going to bring the x over here. So it was 4x e to the x squared, but I'm going to rewrite it like that. Think about the chain rule first. Why is there a product here? Well, the derivative of the inside function is 2x. Okay, I need 2x. I currently have an x. I can multiply it by 2. You could borrow a 2 from that 4 out there. You could turn that into a 2 and you could pull the 4 in. A lot of people just like to factor the constant out every time and balance it. So if I multiply by 2, I'm going to need to factor out a 1/2. Reverse the chain rule. Derivative of the inside function goes away. E to the x is its own derivative. Out front, you're going to have a 2, and then you'll have a plus c. And again, if you try taking the derivative of that, I think you'll see that you do get the right answer. Next one, it's an integral of 3 cosine to the 4th of 2x sine of 2x dx. Of course, your inside function there is a cosine. That's the quantity cosine to the 4th. Derivative of the inside function is -2 sine of 2x. So we need a -2, and we need to balance that with a -1/2 out in front. Okay, so be careful there. Derivative of cosine is negative sine. Anyway, at that point, derivative of your inside function goes away. Raise your power by 1. That's going to be cosine to the 5th of 2x. And, of course, that means you also need to divide by your new power. And out in front here, -1/2 times 3 is -3/2. So when you multiply all that together, you're going to get -3/10 cosine to the 5th of 2x. Inside function doesn't change, plus c. All right. Number 4, it's an integral of a square root. I'm going to rewrite it as the quantity 4x minus 5 to the 1/2 power dx. Derivative of the inside function, you're always trying to reverse the chain rule first. Derivative of the inside function is a 4. We need a 4 there. We don't have it, so we're going to have to balance with the 1/4 out front. Remember, if I did have it, you're not going to balance. You're just going to have the derivative of the inside function go away. Reverse the chain rule. Derivative of the inside function goes away. Reverse the power rule. Your power is going to raise by 1. You're going to divide by that new power. You've got that 1/4 out in front. Okay. Remember, dividing by 3/2 is the same thing as multiplying by 2/3, which is probably how I would do that. And if you simplify that there, I believe you're going to end up with, that's going to be 1/6, right? Because the 2 and we can cancel a 2 out of both parts there. So it looks like it's going to be 1/6 times the quantity 4x minus 5 to the 3/2 plus c. All right. Number 5. Be careful with 5. The parentheses are only there for the dx. So you basically have the function 3x to the 2/3 plus 5x squared. The whole thing is being multiplied by dx. But anyway, really I can just break this up into 2 separate integrals. Take the integral of that and the integral of that. The parentheses are to the first power, so there's no chain rule necessary here. So raise your power by 1, divide by the new power. 2/3 plus 1, that would be 3/3. That would be x to the 5/3. You're going to divide by 5/3, which is the same thing as multiplying by 3/5. Okay? And then over here, raise the power by 1, divide by the new power, and we'll get that. So it looks like it's going to be, if I'm doing this right, 9/5 x to the 5/3 plus 5/3 x cubed plus c. And again, if you have a little extra time, you might want to try taking the derivative there and making sure that it actually works out. I think I'm doing it off the top of my head. I think it does. All right, number 6, the integral of 3 to the 5x dx. Derivative of the inside function is 5. We're going to need to offset that with a 1/5. Remember, when you take the derivative of something like 2 to the x, the derivative is itself times the natural log of the base. So reversing the derivative means we're going to divide by the natural log of the base. So we're going to have a 3 to the 5x. We're going to divide by an ln of 3. We've got that 1/5 out in front, so we can write that as 3 to the 5x over 5 ln of 3, and don't forget your plus c. All right? Let's see here, I'll try to conserve some paper. Try number 7. 7 is the integral of x squared minus 3 quantity squared dx. Notice the derivative of the inside function is 2x, and we don't have an x out there. So we can't do this unless you FOIL this out. That's really your only option. So that's going to be x to the 4th minus 6x squared plus 9. And we're taking the integral of that whole thing. And now it's just a power rule problem. Raise the power by 1, divide by the new power, raise the power by 1, divide by the new power. That's going to be minus 2x cubed plus 9x plus c. And again, that's a pretty easy one to check as well if you want to. And finally, the last of these integrals, we've got a cosecant squared of 4x dx. Negative cosecant squared is the derivative of the cotangent function. We're close to having what we need, but if I want it to be a negative cosecant squared, I'd need to balance it with a negative out in front. And of course, it's going to be a negative 4. Well, we need a derivative there, basically. Derivative of the inside function is 4. We're going to balance it with a 1/4. So you're going to have a negative 1/4 out in front. Derivative of cotangent is negative cosecant squared, so this could be a cotangent of 4x, and then you're going to have a plus c. All right, and I think I'm going to stop this video and pick up for part 2 on some of the application problems.